Okay, so in this video lecture, what we're going to be doing is we're going to be looking at creating a chart from experimental data. So why would you want to do that? What is the importance of that? Well, pretty often what happens is after you've performed some experiment, what happens is you end up sharing that information, whether with researchers, your lab partners, the facilitator of the lab, or the public. And oftentimes the individuals that you're sharing that information with may not be very familiar with the actual experiment or may not be familiar with the actual relevance, and you may be trying to get that information across to them. The best way sometimes to go about presenting that information is to present it in, let's say, charts or graphs or tables or whatever. Okay, and one way to go about doing that is to use Microsoft Excel to create those charts and tables so that it's easier for the individual you're passing on that information to understand what information you're trying to pass on to them through the data in a much easier way. Okay, so we're going to be using Microsoft Excel in order to do that. So let's go ahead now. We have sheet number 2 here. We're going to use sheet number 2 in order to create first a table and then a chart from that table, okay, from let's say a pretend experiment that we conducted. In that experiment, what we'll be doing is we'll be looking at voltage, or let's say what we did was we looked at voltage, current, and resistance. And in that experiment, we are independent variable, meaning the variable that we were changing, actively changing through the experiment, in this case is, let's say, current. Okay, so let's go ahead and type current here. And we were measuring current, let's say, in milliamps. All right. When we were changing the current, we started out with, let's say, 1 milliamp. We went to 2 milliamps, 3 milliamps, 4 milliamps. We're going to make this real easy. And 5 milliamps. And let's say as we were changing the current, we were also checking the voltage that was being produced or being dropped across some given component. Okay, and that voltage, let's say, in this case, is our dependent variable. So as we change the current, the voltage within the circuit actually change. So go ahead and type voltage, and this is our Y um, data, or dependent variable data, and we're measuring in volts. Okay, so we put volts there. All right, and let's say the data that we got back when we put in 1 milliamp current, we end up getting 2 voltage being dropped across component. Then in this case 4 volts, in this case 6, and so on. This would be 8, and again we're making this easy, so let's go ahead and make this 10. All right. In addition to current and voltage, let's say we ended up finding standard deviation. Okay, let's just pretend that we found a standard deviation for the current. And let's say, let's go ahead and the dev, and we're going to say that this is for the current. So we're going to put a letter A here. Okay, and let's say that standard deviation, again, we're going to make this really simple. Let's say that deviation was 0.1 in terms of deviation. And let's say it was that for all of them. Okay, so we had a deviation, standard deviation of 0.1. Let's say we also had a standard deviation then for the voltage also, so we'll put V here. And in this case, let's make this 0.2, and we're going to make it 0.2 for all of them. Okay. Okay. So now we have our data all typed into our table here. So our table has now been created. Now let's go ahead and create a graphical output, if you will, of this actual data. Let's start by creating a graphical output for the data of just current versus voltage. And you'll see why later we decide to just do current versus voltage. Okay, so if we want to create a chart now for this, we'll go ahead and highlight, as I did here, highlight the current and voltage, and then we'll click on Insert. And what we want to do is we want to insert a chart into this Excel spreadsheet. All right, so we can move over here to charts. Now, because of the type of data that we were collecting here, where we had dependent variable, independent variable, and we have specific values. What we want to do is we want to choose the scatter plot. Okay, scatter plot for our graph or our chart. And the reason why we want to do that again is because we have specific values. We only conducted the experiment at those specific values and of current and got those specific values for voltage in return. And so the scatter plot is a good way to represent this. And so we want to use scatter plot with just the points, not the line in there, because the line would then indicate that we perform more experiments along, let's say, for instance, in between 1 to 2 and so forth, and which that's not what we did. Okay, so if we look here at our chart, you'll notice that on my x-axis, it goes 1 in terms of my points anyway. It goes 1, 2, 3, 4, 5, 6, and so forth. Up here on my y-axis, it's 0, 2, 4, 6, 8, and 10. So what that seems to indicate by looking at the data that we started out with over here, and I'll move this out the way just slightly. The data we started out with, what it's indicating is that on our x-axis, which is down here, our first column was put on the x-axis, and our second column was put on the y-axis. Now that's the way that Excel typically does it, and that in this case, this is the way that we wanted it to be done anyway. Okay, so we have our points that are plotted here. Now, if you look at the chart, you realize that there's no information on our X and Y axis. Now, because I know what I created, this makes sense to me. So I could tell you that this was the X for the current and this was a Y for the voltage. But let's say this is someone, I pass this on to someone that isn't familiar with the data. This means nothing to them. So what we want to do is we want to add titles, axis titles to our chart here. And we do that by clicking on the plus sign. And we look for axis titles. We put a check mark in there. And then we get, whoops, let's put that back in there. We get axis titles, as you can see. Okay. So let's go ahead now and change those axis titles. So down here again, this is current. Okay. And then I move over here to my y-axis. I double click to get in there, and then I highlight, and I'm going to type my voltage, and I put V. Okay, and that gives me my voltage in there. Now I double clicked, which highlighted, double click on the left mouse button, which allowed me to go in there and type in the information. All right, so now my voltage information is there, my current information is there. Because of the type of experiment that I did, I know that this the results here are going to give me the slope of the line here is going to give me my resistance. So I'm going to go ahead and type that this title of the entire graph here or chart is named resistance. Okay, you name it appropriately for whatever experiment that you're doing. All right, so now this actually has more meaning to, and I'm going to click this off here. This actually has more meaning to someone that actually reads it. Okay, they can now tell that this is about checking resistance, and you checked and you had a independent variable of current and a dependent variable of voltage, with the current being milliamps, and this is in volts. All right, so we've added the titles. Um, we haven't done anything with these standard deviations yet. So let's go ahead and do something with that. The standard deviations we can use for expressing error bars. And let's go ahead and say that we're going to choose error bars here. And you'll notice that the table already, they already added substitute error bars in there. We don't want those. Let's go ahead and add our standard or our customized values, because we actually have our own values. So we move over here, we click once on the arrow here, move over here to more options and click one more time. All right, and let's go ahead now. Now this has the horizontal bars, and the horizontal bars are going across. Those are for the X. Okay, and you'll notice that what we're going to do is we're going to choose that the bars to go, the arrow bars to go both in the positive and negative direction versus just in one direction or the other direction. Okay, and we're going to scroll down here to custom. and we're going to specify our values, and that's because we already have values. Okay, so we go ahead and click on the values here, and in here ask where do you get the positive error values from. We're going to say we get the positive error values from here, and we're going to get the negative error values from here also. So this means just plus or minus the standard deviation is what it's pretty much saying. Okay, and we click on OK, and now you'll notice that the error bars are really small. Okay, and they're actually highlighted by these bubbles that are around here. Okay, so that's the horizontal error bars. Let's change the vertical error bars now. So if we click on the error bar option, go down to series 1 and click on Y error bars, we can now go and choose our Y error bars. Again, want to pick both plus or minus error bars, and go down here to custom because we have values. Click on the actual box there. This box pops up. Want to click on this, tell it where to get the positive error bars from, and that's here. Let's move this out of the way just a little bit. Click on this one, and then we choose these again. Okay, and then click on OK, and you'll notice now that those error bars in the vertical have actually shrunk. Okay, so now that we have our error bars in there, just a few more things I want to demonstrate. Let's say we wanted to find or put our trend line in there because we want to be able to show the slope of our data, right? So let's go ahead and choose a trend line, and you'll notice the trend line immediately pops up there. And you have options to choose different trend lines. You have linear, which is the one we have. Then you have the exponential, so on and so forth, or you can choose your own. Based off of our experiment, we expect a linear result, so I left the linear in there. You can, what we'll do is I'll pick more options just to show you the other options that are in here also that you can choose from. Okay. In here, I want to add a few other things. What I want to add also is I want to add the display equation onto the screen here. You'll notice that the y is equal to 2x. The 2x, if you remember our slope-intercept form, y is equal to mx plus b, where m is the slope. This 2 is the slope. So what this is telling us is that the slope of this line is 2, which means the resistance uh, is 2 kilo ohms from based off of the information here. See, that's the sort of stuff that you can gather just by reading it. If let's say I was someone that wasn't familiar with what you were doing. So in this case, again, slope is 2, which means my slope of the resistance is 2 kilo ohms. All right, and we can see that from the equation. Something else that we can put on here is the r squared value. We can add that on there. And what the r squared value is, if you're not very familiar with that, r squared value tells you how much of a correlation there is between the data that was collected from the experiment and the trend line that was put on the graph. If there is a strong correlation between the two, then your value for r squared would be a value close to or exactly 1. Okay, if there's a strong correlation. If there's not a strong correlation, what happens is that value ends up being equal to 0 or being closer to 0. Okay, so that's the importance of that r squared value. All right, so let's go ahead and close this box down. All right, so this is now your graph from the information, the table from the information collected from the experiment. And you may use this now in, let's say, lab reports or whatever to demonstrate or to show people the importance of your data or to help them understand better what you were doing. All right, so this has been a presentation again on creating a chart from experimental data uh, by using Excel. Please do check out my website, or you can find my or subscribe to my YouTube channel. Thank you very much.